In this video, I'm going to be introducing exercise 5b using pronumerals. The examples I'm using are all from your textbook. So we start off with the exercise being told 3 pencils from your pencil case have been placed on the desk. The total number of pencils you have depends on how many pencils are left in the case. So we have 3 pencils on the table, on the desk, and we have a number of pencils in your pencil case. So the first question says to us, how many pencils do you have in total if there are 2 pencils in the case? So in the case there are 2 pencils, and we are told at the start that there were 3 pencils that were placed on the table. So we have 2 in the pencil case plus 3 on the table. That is a total of 5 pencils. The second part says to us that we have the 3 pencils on the desk, but this time we have 5 pencils in the pencil case. So we have the 5 pencils in the pencil case plus the 3 in the desk. That gives us a total of 8 pencils. The second part of this example says to us, copy and complete this table. So we have a table of values to show the relationship between the number of pencils in the case and the total number of pencils. Now we know always, as we were told in the question, there are 3 pencils on the desk. So if we have 1 pencil in the case, plus we have 3 outside on the desk, 1 plus 3 is 4. If we have 2 pencils in the pencil case, 2 plus 3 is 5. If we have 3 pencils in the pencil case, plus our 3 on the desk, 3 plus 3 is 6. If we have 4 pencils in the pencil case and 3 on the desk, 4 plus 3 is 7. If we have 5 pencils in the pencil case, plus 3 on the desk, 5 plus 3 is 8. If we have 6 pencils in the pencil case and 3 on the desk, 6 plus 3 is 9. We've now completed the table. Number 3 says to us, what are the 2 variables in this relationship? Variables are the things that can change. So we have 3 things in this question. We have the number of pencils that are in the pencil case. That can change. So in is a variable. The number of pencils outside the pencil case was always 3. That's why we were adding 3. So that doesn't change. That's not a variable. We have, though, the total number of pencils, which was our number of pencils that were in the case, plus the 3, which gave us the total number which was outside the case. So out is a variable because it changed every time we changed the number of pencils that were in the pencil case. Number 4 says to us, write the rule for the relationship using the words in and out. So we know outside the pencil case, we're going to write the word out. That was the total number of pencils. That's equal to the number that was inside the pencil case plus the 3 pencils that were on the desk. So for instance, I have circled in 4, out 7 in the table in part 2. So we can see there, out, which was 7, was equal to in, which was 4, plus 3. 4 plus 3 is 7. Now for the next part of this example, it says to us, mathematicians have developed a shorthand way of writing variables. That means we're not going to write the word in and out. Instead of writing the words in or out, we're going to replace the words with a single letter, using a letter to replace a word. When we use these letters are called pronumerals. I've highlighted that in yellow. So, now we're going to look at question number 5. This question says to us, which formula matches your rule? What we'd written in words was out was equal to in plus 3. It says to us, for example, replace in with x. So instead of writing in, I'm going to write x. And instead of writing out, we're going to write y. I'm going to put the equals and the plus sign in and the 3. So y equals x plus 3, which is option B. Question number 6 says to us, copy and complete the new version of the table of values using the pronomials x and y. So we have x is equal to 1, which means y is equal to 1 plus 3, which is 4. We have x is equal to 2, so y is equal to 2 plus 3, which is 5. We have x is equal to 3, so y equals 3 plus 3, which is 6. We have x is equal to 4, so y is equal to 4 plus 3, which is 7. We've got x is equal to 5, so y is equal to 5 plus 3, which is 8. We have x is equal to 6, y equals 6 plus 3, which is 9. The last part of this example says to us, use the relationship to work out how many pencils you have in total if there are 11 in the case. So in the case, there is 11. We are using the pronumeral, the letter x, to represent in. So x is equal to 11. We have the relationship y equals x plus 3. That is from question 5. So y, the number of pencils in total, is equal to 11, the number of pencils in the pencil case, plus 3, the number of pencils on the desk. So y is equal to 11 plus 3, 14 pencils in total. The next part gets us to write a formula. There are 4 symbols to be aware of. Plus, we add things. Minus, we subtract things. Times, we multiply. And divide. So, in this particular example, they're only using times and divide. So we're going to look at part A. Part A says to us, out equals in times 4. It says to us, use the letter A for in and the letter B for out. So where there is out, I'm going to write B equals in in is A times 4. Now as mathematicians, A times 4 we write as 4A. Part B of the question, we have this time out equals in divided by 5. So where there is out, I'm going to write B equals in. Where there is in, I'm going to write A divided by 5. Again, as mathematicians, when we write divided by 5, we write it as A over 5, like a fraction. Now we're asked to look at a table of values and try and write a formula. Now, the pronumerals they're using are X and Y. So we're going to have Y equals something. Now, if I look at my X's, I've got 5 going with 3. One way I can get from 5 to 3 is by subtracting 2. 5 minus 2 is 3. Now I want to have a look to see whether that is the same with this next pair of numbers. 6 to 4, 6 minus 2 is 4. It's looking good so far. 7 to 5, 7 minus 2 is 5. 8 to 6, 8 minus 2 is 6. And 9 to 7, 9 minus 2 is 7. So every pair had the same relationship. So Y equals the number at the top, X minus 2. If I again pick an example, I'm going to pick 8, 6 just to show you. 6 is Y equals 8, which is X for my pair, minus 2. And 8 minus 2 is 6. I can see it works. The last example gets us to use a Cartesian plane. I have already drawn the Cartesian plane. You can see it on your screen. What it says to us is plot. So we're going to plot. Now it says the graph of the relationship shown. So in chapter 4 we looked at points. We have got a pair of points, 1, 6. X is 1, Y is 6. So like we did in chapter 4, we go across 1 in the X direction and we go up 6. So I am going to dot on my screen so you can see what I'm doing. Across 1 and up to 6, where I'm marking my point. The next point I have is the point 2, 7. 2 across, 7 up. So go across to 2, up to 7, and mark in my point. The next point I have is 3, 8. So I'm going to go across 3, up 8. So across to 3, up to 8. The next point I have is 4, 9. So I'm going to go across 4 and up 9. Across to 4, up to 9. Last point is the point 5, 10. So I'm going to go across across 5, up 10. So across to 5 and up to 10, and I mark in my point. Normally you would not mark in the dotted lines. I have just done that so you can see what I was doing.